In this lecture, I'm going to show you how to measure the accuracy of your models. Now, in order to do so, first we need to split our data set into two sets, one for training and the other for testing. Because right now, we're passing the entire data set for training the model, and we're using two samples for making predictions. That is not enough to calculate the accuracy of a model. A general rule of thumb is to allocate 70 to 80% of our data for training and the other 20 to 30% for testing. Then, instead of passing only two samples for making predictions, we can pass the data set we have for testing, we'll get the predictions, and then we can compare these predictions with the actual values in the test set. Based on that, we can calculate the accuracy. That's really easy. All we have to do is to import a couple of functions and call them in this code. Let me show you. So first on the top, from sklearn.model_selection module, we import a function called train test split. With this function, we can easily split our dataset into two sets for training and testing. Now, right here, after we define X and Y sets, we call this function. So train test split, we give it three arguments, X, Y, and a keyword argument that specifies the size of our test dataset. So test underline size, we set it to 0.2. So we are allocating 20% of our data for testing. Now, this function returns a tuple, so we can unpack it into four variables right here. X underline train, X underline test, Y underline train, and Y underline test. So the first two variables are the input sets for training and testing, and the other are the output sets for training and testing. Now, when training our model, instead of passing the entire data set, we want to pass only the training data set. So X underline train and Y underline train. Also, when making predictions, instead of passing these two samples, we pass X underline test. So that is the data set that contains input values for testing. Now we get the predictions. To calculate the accuracy, we simply have to compare these predictions with the actual values we have in our output set for testing. That is very easy. First, on the top, we need to import a function. So from sklearn.metrics, import accuracy underline score. Now at the very end, we call this function, so accuracy score, and give it two arguments. Y underline test, which contains the expected values, and predictions, which contains the actual values. Now, this function returns an accuracy score between 0 to 1. So we can store it here and simply display it on the console. So let's go ahead and run this program. So the accuracy score is 1 or 100%. But if we run this one more time, we're going to see a different result because every time we split our data set into training and test sets, we'll have different data sets because this function randomly picks data for training and testing. Let me show you. So put the cursor in the cell. Now you can see this cell is activated. Note that if you click this button here, it will run this cell and also inserts a new cell below this cell. Let me show you. So if I go to the second cell, press the escape button. Now we are in the command mode. Press D twice. Okay, now it's deleted. If we click the run button, you can see this code was executed and now we have a new cell. So if you want to run our first cell multiple times, every time we have to click this and then run it and then click again and run it. It's a little bit tedious. So I show you a shortcut. Activate the first cell and press Control and Enter. This runs the current cell without adding a new cell below it. So back here, let's run it multiple times. Okay, now look, the accuracy dropped to 0.75. It's still good. So the accuracy score here is somewhere between 75% to 100%. But let me show you something. If I change the test size from 0.2 to 0.8, so essentially we're using only 20% of our data for training this model, and we're using the other 80% for testing. Now let's see what happens when we run this cell multiple times. So Control and Enter. Look, the accuracy immediately dropped to 0.4. One more time. Now 46%, 40%, 26%. It's really, really bad. The reason this is happening is because we are using very little data for training this model. This is one of the key concepts in machine learning. The more data we give to our model and the cleaner the data is, we get the better result. So if we have duplicates, irrelevant data, or incomplete values, our model will learn bad patterns in our data. That is why it's really important to clean our data before training our model. Now, let's change this back to 0.2. Run this one more time. Okay, now the accuracy is 1, 75%. Now it dropped to 50%. Again, the reason this is happening is because we don't have enough data. Some machine learning problems require thousands or even millions of samples to train a model. The more complex the problem is, the more data we need. For example, here we're only dealing with a table of 3 columns, but if you want to build a model to tell if a picture is a cat or a dog or a horse or a lion, we'll need millions of pictures. The more animals we want to support, the more pictures we need. In the next lecture, we're going to talk about model persistence.